Hello, I'm Xian and I'll be showing you the new point cloud features in BricsCAD V22 today. Let's start with our new UI. So for point clouds now in V22 we have an entirely new tab in the ribbon. So as you can see here, where all the icons are for specific point cloud features. Here I opened the Point Cloud Reference Manager, where I can see all the available point clouds on my computer here. Since the point clouds scans are usually very large, we developed our own data structure focused on performance. So we only show on screen what is relevant. So since we have our own data structure, we need to pre-process traditional point cloud file formats to our own data structure and create a new pre-processed file. So here I'm doing that. Note that we also support all popular formats like E57, .lis, PTS, PTX, RCP, and RCS. In V22 we also support LAZ files. So now we can just click OK and just attach this point cloud file into our drawing and automatically start the pre-processing process. In the manager you will see also a progress bar, so you know more or less how long it's going to take. Then in the same manager we can also check out the cache settings, so you will automatically be directed to the settings and you can change some cache settings for the point clouds, for example changing the path or changing the maximum allowed gigabytes on your disk and so on. Alright, the pre-processing process is a background thing, so we can actually go ahead and, for example, scroll around and do other things while it's loading. Alright, so this is done. So once I've pre-processed one point cloud, I can always reuse it in other drawings as well. So like that, I can always insert or delete certain point clouds from this manager. Here I'm opening a new drawing and using the manager again, inserting another point cloud that I've pre-processed before. So like this, I can really quickly get back a new point cloud. Alright, so this is just another point cloud from a loft complex. And let me zoom a little bit more in and then show you some settings to adjust the visual settings for points of the point cloud. First thing we can do is increasing the point size of every point. So as you can see here, I'm increasing the point size and you will see it reflected in the drawing as well. Here I'm decreasing it, and when I'm near 1 or 2 you will see that it's really small, so you see all the gaps in between as well. Uniquely in BricsCAD we have point cloud adaptive display, so typically scans have regions with higher and lower density. And a very powerful way to display a point cloud in a more natural way is with this point cloud adaptive display. So this will set the size of a point depending on the local density of points. Regions with a lower density will have a filled look instead of an empty space. So you can see every time I stop orbiting or moving around, the points will recalculate, so it will automatically adapt to its density. Last thing I want to mention for visual styles is the point cloud point max. So that defines the maximum number of points in my drawing. So here, for example, I put it to 500,000. So you see it's less detailed. When I put it back to 6 million, for example, there you will have a more detailed point cloud. Snapping to a point cloud is a separate snap option in BricsCAD, and this can be very useful when using point clouds combined with other 3D geometry. So here you can see in eSnaps we have a separate option called point cloud nearest point. And like this you can, for example, measure the distance between points. Here I'm, for example, moving a certain point of the point cloud to the origin. So this is how you can use this specific point cloud snapping feature. Next up is aligning the point clouds. So as you can see, you see that the point cloud is not perfectly aligned with the UCS. You can do this manually by rotating it. So here I'm doing this with the manipulator. What we also can do is automatically align this point clouds with the origin with point clouds align. So this is a background thread as well, so you can orbit around or draw some other things while this is calculating and aligning your point clouds. So now if you just zoom extend, you will see that point cloud is aligned with your UCS. Next up for viewing a point cloud is cropping. So we have our traditional crop to cut off parts of the point cloud. Cropping a point cloud doesn't mean that the data is lost. It is just not displayed, and it will not be taken in account when using other point cloud command that you will see later on. You can always uncrop to show the full point cloud again, but if you want to really keep only one part of the point cloud, you can export this point cloud as well, and this will write a new file to the disk with only the visible points on screen to a PTS file. Here I'm using your regular crop and cropping inside. So here you see the result of that. So for V22 we actually have an extension to this crop functionality. So let me just first uncrop this point cloud, and let me zoom into another part of the point cloud and draw a box somewhere near. So here I'm just drawing a regular solid box somewhere in this part of the point cloud, and what I'm gonna do now is crop solid. So it will turn this solid into your crop area. So you can choose for inside and outside as well. So here this is inside, and you can still see this solid right here, and you can actually still use direct modeling tools on it. So for example, if you select a surface and drag it and push and pull it to make it bigger, you will see that the cropping of the point cloud will also adapt to it. Alright, so now we can, for example, select the box that we created and open the properties panel. So you see it's still a 3D solid with some extra properties to it for cropping. So here, instead of inside, I changed the cropping to outside, and again I can still edit this box size with push and pull to create the view that I desire for this point cloud. So like this, I can, for example, make a hole in the building by just using this crop solid. Let's delete that and give you another use case for crop solid as well. Let's zoom into another part of the point cloud. So here at the terrace, for renovations or implementation projects, if you want to delete a specific wall of a point cloud, for example, you can do this with point cloud crop solids with the option outside. So we can edit and hide certain elements of your point cloud. So what I'm doing here, so let's say we want to open up the living room to the terrace, and we want to create a very big window or something like that here where I draw this solid box. So like this, I can change the size of this box and move it around a little bit to create this hole in the point cloud. So you see here I'm just still adjusting some dimensions, and when I'm happy with the size of the box, I can actually just select the box and hide it. So like that you have your full point cloud, but you will have some things deleted or the implementations done that you want to create, to see if it works and to see how it looks. So like this, you can edit your point cloud and delete some parts out, very specific parts. The same way, you can just unhide or show it back again, and you will have your solid, and if you delete your solid, you will still have your full point cloud. Now, regular section planes and volumes work on point clouds too, and they can be used to show parts of a point cloud. So the main difference between sections and cropping is that point cloud crop will only clip the point clouds, while sections will actually clip all geometry. So if you have regular walls or other solids, it will be clipped too. So here I did it manually, adding a section, but for point clouds we have point cloud detect floors. So you can add it manually, but here we can actually create these section volumes automatically. So it creates horizontal section volumes for each floor of the building by searching regions of points with a similar Z value. So like this, you can also navigate through your point cloud. And lastly, about viewing point clouds is with the bubble view. Points can have their color information or location information in it, and a point cloud can also contain certain information on scan positions. When we have fixed scan positions, we call it structured point clouds. And unstructured point clouds are the ones that don't have information on the scan positions because they were made with, for example, a mobile scanner, like a moving drone. When you work with structured point clouds, we will use this information during import. So in V22, during import and pre-processing, bubble views are created. And these are based on a spherical image from one scan position and can be used in a pop-up viewer. So these are the green transparent spheres right here, and you can turn it off and on from the properties panel. When you hover over one of the bubble views, when you double click, this pop-up viewer will be shown. So you can see how this image is according to its scan position. Now there are 3 visual modes for this bubble view. First thing, we have the color mode. So these are your regular RGB colors as captured by the scanner. Then if I hit tab, you will have the normal vector mode corresponding to the colors used in the model space for X, Y, and Z. A depth map, grayscale image of according to the distance of a point and the scanner position, and then we are back at the color mode. One thing we can do is align the view with the model space. So if I hit Ctrl A, you will see that I have now the same view as the bubble viewer in my model space. So now my view is exactly the same as from the bubble viewer, and I can zoom out again, and now my view is actually on perspective instead of ortho. I can put it back where it was, but this was just to show you how to align your bubble view. Now let's zoom out a little bit and show you what else you can do with these bubble viewers. Let me close back my section so you can see the full point clouds. Now I'll be drawing a line on my point cloud. So here I'm just using your regular line command and using the point cloud's nearest snapping points to snap on certain parts of a point cloud where I want to have this line, like so. Another way to do this is with the bubble viewer. So in V22 you can do all of the drafting in the bubble view as well. So if I double click on my bubble view right here and place my pop-up viewer somewhere on the right, so I can see at the same time what's happening in the model space. So let me just find a good spot and start to, for example, draw on the facade right here. So I have some outline of this part of the facade right here. So you will see that I have dedicated snapping tools and cursor that shows me where I'm drawing to. So like this here, I drawn a polygon and closed it. On the other side, in the model view, you can see that I have a polyline right here, based on the facade that I had here in the bubble view. The same thing for the contour of this window, for example. Let's draw a rectangle around it like this. It's the same. The same thing for adding a block, for example. So just insert a block that I had for this light fixture and just click on OK and just put it here in the bubble view like so. For the other one right here as well, and also the last light fixture there. You will see that it will all be reflected in the model space as well. So if I go back to the model space and not in the bubble viewer, you will see that these little blocks for the light fixtures are added as well. Lastly, to annotate, for example, this little step right here, to dimension things, you can also use the bubble viewer to have a more correct point of input right here. So you see now this step is 1.26 meters wide. Not only can you use dimensions in bubble view, you can also create text in bubble view as well, and this will be reflected in the model space too. So here I've selected a space on the facade in the bubble viewer and type in some random text, so in this case facade. You will see that it will be reflected onto the model space too, with the text correctly placed on to my terrace facade. So now if I zoom out a little bit and hide my point cloud, you will see all the extra drafting elements that I did right now within the bubble view. You will see this all reflected in the model space too. Now let's start to also create some 3D geometry, so not only 2D, but let's go over to some 3D elements as well. So let me create a section right here to the upstairs rooms, and let's create some geometry for this level. And just like last year, we can use Fit Planner for this. So for those who don't know, Fit Planner is a V21 feature to automatically generate 3D geometry. So the command creates a surface or a solid after selection of a point of the point cloud, but of course we improved this workflow for V22. So here I'm using Fit Planner in model space, and depending on the size of the point cloud, it will take more time to generate compared to in bubble view. I will show you later, because it takes multiple scan positions in account and not just one like in bubble view. This has two major advantages. So it can create larger surfaces that are lying in multiple scan positions, and it can detect wall or slab thicknesses since it takes the opposite surface in account as well. So here you see I can also toggle into the different options, so surface, contour and solid. So let's choose solid, and let's go for another option for Fit Planner for another wall called noisy. So this is a V22 feature where if you have a less dense point cloud, you can basically choose more points of input, so that the command can predict a little bit better what kind of geometry or surface you want. So like this, you see I have a surface of my hallway. So this was Fit Planner in model space, but let me also show you how you do this in the bubble viewer as well. So let me go back to the rooms here and hide this wall that we just created, and double click on this bubble view of this room. So when the bubble viewer is open and you launch Fit Planner, it will automatically know that you want to do Fit Planner in bubble view rather than in model space. So here you have your dedicated cursor again, and you can just click on it, and the purple is basically a preview of the surface that you're going to create. Of course, for example, if you just like to have a certain part of this wall created, you can always modify it like this and create it your own and press enter. Like this, again, this geometry will be created in the model space too. So when you go to the model space and select this little surface, you will see it will be perfectly reflected into the model space as well. So this was the little surface that we have drawn. Okay, so now let's go back to your regular fit planner option. So here I'm back again in this room and doing fit planner on all of the surfaces of my room right here, so I can create like a room contour kind of geometry having all 6 surfaces. So I can just click on every surface, even ceiling and floor, and everything that turned purple will be previewed in the model space. And here I'm also going for the option select opening. So if I now select the opening, as in the door opening, for example here, and the window opening as well, then there will be a polyline created according to the contour of this opening. So if I now accept, every surface turned green, and if I look at my model space, you will see all these surfaces are created for me. And if I look a little bit more clearly, there is also a polyline according to the contour of my window, as well as the contour for my door. So like that, I can quickly select the polyline and just use extrude to create a hole in this surface. So if I now hide my point cloud for a moment, you will see that indeed we have all our surfaces, and at the location of the window and the door there is a hole created as well. Alright, so let's move on to a next option of Fit Planner, maybe the next room somewhere. Also opening it in bubble view and launching the Fit Planner command. Now I'm going to choose the same wall, so the 4 walls and then the ceiling and the floor, but instead of just entering to confirm my surfaces, I'm going to tick on the option for automatic stitching as well. So stitch surfaces, and by that it will actually create one solid of my 6 surfaces. So if I now switch it on and then press accept, you will see instead of the surfaces that we have created before, now it turned it into one big solid. So this solid is just your regular solid that represents the room volume. Like this, I can still, in the same command of Fit Planner, switch to another bubble view and do the same thing. So always 4 walls, and then 1 ceiling, and then 1 floor, and then using the stitch option it will create a solid for you. So here I'm doing the same thing for the hallway. Accept, and it turned green, and then you see in the model space it turned into a solid as well. Lastly, for the staircase right here, same thing. It doesn't really always have to be 4 walls. So here in this case I have a slightly slanted rooftop as well. So here, instead of the 4 walls and the ceiling, I'm also selecting the slanted part right here and taking this into account as well. Alright, and now the floor, and if I now press enter, it will also automatically stitch my surfaces together to create a solid. So now I can close the bubble viewer and zoom out a little bit to see the space solids. Let's unclip this section right here as well, so you can see the slanted part too. So as you can see, this is the result of our fit planner commands. The first room, of course, was just plain surfaces right here because we didn't opt for the option automatic stitching. Here I switched into another drawing where I've already done the other rooms as well. So the same way with Fit Planner in Bubble View, I stitched all the surfaces together to create solids. So here we have multiple solids. But in BricsCAD we can also generate geometry as it is. So any skewed, sloped, or not perfectly vertical solids we can still create in BricsCAD. You can see it here. In this case, some of the surfaces of the generated blocks are not perfectly in the slope of 90 degrees or 0 degrees. For that we can use optimize. So optimize, it's a command that helps you flatten, align, or rectify any of your 2D and 3D geometry to simplify your geometries. Let's use the default settings and click on OK to simplify our solids. So this is the result. Let's open up the properties panel again to see the difference. So here you can see the same surfaces that I selected before now have a perfect angle slope, like 0 or 90 degrees. So now everything is set for me to do BIM invert spaces. BIM invert spaces is a new V22 command, and what it does is basically it automatically creates walls and slabs based on the input of spaces. So here we created our space solids already. So by that, or according to that, it will create individual walls per floor in this case for me, and here is the result of that. Of course you can still continue to optimize it, but as you can see already, it's properly classified as well as roof, as wall, anything like that. And if I open up a section, you will see the inside as well. That looks pretty good. Again, wall, roof, slab, everything is already nicely classified with the proper information to it as well. So here, floor 1, floor 0, location, and so on. So this is already properly classified, so this is a good start for your BIM model. The next thing we can do is to export it into an IFC to further share it to other people of the same project. So here I'm choosing export and I'm choosing an IFC file accordingly and click OK. So in an instant my IFC file will be created. So if I just check it in Solibri, you will see that my model has nicely came along, as well with the proper information and property to it. Like this, you see some rooftop information as well as some information from the other slabs and walls and so on. So you can quickly export this in IFC as well. Back to my project itself. Lastly, what I want to show you is mainly documentation. So go back to this drawing right here, and I want to create some documentation out of it. The main command for that is project section. So this command generates 2D content based on your point cloud. So like regular sections, the section volumes clipping the point cloud can be generated to create 2D lines for a 2D floor plan or a vertical section. So at the same time, the command will also generate a raster image of the point cloud as a reference. So here you see I can choose for adaptive, so then it will load a little bit quicker. And let's apply it and see the result of that. So here I had option detect walls on, so lines will be generated from the point cloud points that the section cuts through. So as you can see here, I've created this image of my point cloud floor plan basically, and the green lines are the lines that are generated through this command. Here I'm adjusting some tolerances to create or regenerate the lines. So like that you can still adjust some tolerances and so on within the command. So here you see it's just your regular lines that we have created from this project section command. Another way to create this 2D floor plan is with fit polyline. So this is a new V22 command that you can use in regular 2D drafting, but you can also use this with point clouds as well. But let me refer you to the breakout session of drawing optimizations where Hannes will explain a little bit better how fit polyline works. Another use case of the project section is actually with an already existing or created model. So this is another workflow where a point cloud is a source of high quality images in combination with an existing or already made BIM model. So here you see I already have the BIM model, and on top of it I have the point cloud. And like this I can generate a section as well. So let's do a vertical section instead. So if I open it, you will see both laying on top of each other, the BIM model and the point cloud together. So that looks pretty nice, and we can generate a section out of it. So if I generate a section out of it, it would be your regular BIM section generate with compositions, tags, and so on. But you will also have your point cloud raster image underneath it as well. So let's do that and see what the result is. And now you can see the progress bar running. It will take a little bit longer than before because I put the resolution for the image to finest. But you already can see the result of the generation of the BIM models. So as you can see, the compositions are there already. Oh, and here is the rest of it. So now I'm in model space, and if I zoom out, you can see the image underneath the drawing as well. I can select the image and hide it, so you can see the difference between the point cloud image and then your regular section generation. You can still start to annotate this drawing like your regular documentation. So for example, tag some information for the walls or the roof and so on. You can add in dimensioning, tags, other information as well. So like this you can document your section, and then you can just bring back the image like so, and this is the result of your project section. So this was my session for point clouds in BricsCAD V22. I hope it was interesting, and I hope you can try it out yourself as well. If you have any feedback or comments, always feel free to reach out to us. Thank you.